Hi, this is Scott Bateman. This was work that was completed with my PhD student Connor Wilson and my colleague Daniel Ray at the University of New Brunswick. In this work, we present a potential new illusion we discovered while exploring temperature illusions in mixed reality. Visual stimulus, like the color and size of an object, can affect your perception of how an object feels. For example, the size of the object can affect your perception of its weight, and the color of an object can affect your perception of its temperature. These are called sensory illusions, where a visual property of an object, such as its color or size, change our experience of another sensory property. Color temperature illusion is the focus of our work, and it's easy to describe. The color of a physical object influences our perception of its temperature. Different colors have been found to have different effects by changing our perception of an object to be either colder or warmer. Blue and red objects have the strongest effects, with white objects being neutral. So if I were to give you a red object and ask you if it was colder or warmer than a blue object of the same temperature, would the illusion cause you to feel that the blue object is warmer or that the red object is warmer? Any guesses? Well, you're probably wrong if you're not familiar with this type of illusion. Surprisingly, the color temperature illusion leads us to believe that the blue object is warmer. The current prevailing theory for why the illusion works this way is related to our expectation of objects' temperatures based on color. Since we think of red as a warm temperature, when we touch a red object, that we then underestimate its actual temperature, believing it to be colder than it actually is. And blue objects that we expect to be cold lead us to believe that they feel warmer than they actually are. And of course, this happens without conscious thought. The size-weight illusion works similarly, where people perceive larger objects to be lighter than they actually are and smaller objects to be heavier. But these illusions have been established using physical objects and not with interactive systems. In mixed reality, we can change a physical object's appearance by superimposing graphics on top of it. So we can change a red ball to any color, like blue. If we do, how might this change our perception of it? Would the color temperature illusion still be present in MR, where things might look realistic, but where we know the objects are not real? Surprisingly, we found no previous work that had tested the color temperature illusion in MR. So in this work, we first wanted to see if we could recreate the color temperature illusion in MR. We wanted to know if a physical item, that is 20 degrees Celsius, placed in your hand but superimposed with a virtual red ball, would be perceived as colder than a virtual white or blue ball. But MR also opens up the door for providing a richer set of visual experiences than just flat-colored objects. So what if instead of holding a red ball, which I expect to be warm, I held a ball that looks like it's flaming and uses graphics and particle effects to add some realistic characteristics? If my expectation was the red ball would be warm, would this visually stronger depiction of warmth lead me to perceive the temperature as being even colder? What about a virtual frosty ice ball? Would this lead me to believe that the object is warmer than it really is, and even warmer than a blue object? So for now, I'll tell you that dynamic graphical effects like these seem to have a bigger effect than colors, but not in the way you might expect. To better understand temperature illusions in MR, we designed a mixed reality system and an experiment to examine the effect of changing the appearance of a physical object on the perception of temperature. And we wish to establish whether the color temperature illusion could exist in MR and whether dynamic graphics might strengthen the effect. And additionally, since previous perception research had not looked at the effects of illusions over time, we were also interested in whether the effect of temperature illusions could be consistent over time. Our experimental system uses a Z-Mini stereoscopic camera attached to a HTC Vive to provide pass-through video to place virtual objects in participants' hands. Participants using our system would hold a gel pack of a specific temperature with an HTC tracker placed on top. This would allow us to provide a consistent temperature stimulus and accurately place a virtual ball that covered the gel pack and the tracker so that the physical objects were not visible. Our system provided 5 visual stimuli. A white ball is a baseline because from previous work it was determined to have no effect on temperature perception. A red ball and a blue ball to allow us to assess the color temperature illusion in mixed reality, and to assess the potential effects of dynamic graphics, we created a fiery ball and an icy ball. For our experiment, we recruited 30 participants with varying degrees of mixed reality experience from our extended university community. 16 identified as male and 14 as female, and they were all able to complete our experiment in roughly 30 minutes. Identical hot and cold packs were used as the temperature stimulus. Some packs were at room temperature, which was 21 degrees Celsius, some were cooled to 7 degrees Celsius, and some were warmed to 33 degrees Celsius. And pack temperatures were verified throughout the experiment using an infrared thermometer before they were used. These temperatures were chosen as they were within the range of temperatures human beings can distinguish between. The task in our experiment was a simple one. Given a stimulus viewed in our mixed reality system, participants simply estimated the object's temperature in degrees Celsius. Our experimental procedure included 3 identical blocks to allow us to identify the effect of illusions over time. To begin each block, while wearing the VR headset, participants were presented with 3 temperature packs without a visual stimulus and were told the specific temperatures of the pack. One 7-degree pack, one 21-degree pack, and one 33-degree pack. These packs acted as anchors. Participants were explained that the virtual balls they would be given throughout the experiment would be within this temperature range. Each block then consisted of the 5 stimuli, one of each of the virtual white, red, blue, fire, and ice balls. Participants would be shown the virtual ball for 5 seconds, asked to hold the virtual ball by placing the pack with the HDC tag on top of their hand for 10 seconds, then to estimate the temperature of the virtual ball. Between each stimulus, participants were asked to rub their hands together for 10 seconds, which was meant to clear any lingering sensations from the previous pack. All anchors and stimulus presented were counterbalanced across participants, and again, the general procedure I just described was repeated across 3 blocks so we could observe whether the effects change over time. Importantly, however, our protocol involved some deception. While the 3 temperature anchors we provided were different in temperature, each of the stimulus we presented were the exact same temperature, 21 degrees Celsius. Our participants were led to believe that they would be different when they were told that the temperatures would be between the 7 and 33 degree packs they felt. Before I present our results, I need to discuss our experiment design, which helps us to interpret our results. Our experiment followed a typical HCI experiment procedure, but departed from the psychophysical experiments used to establish the existence of illusions. These psychophysical experiments would use forced choice between 2 stimulus. For example, which is colder, blue or red? Where in our approach, we asked people to estimate the temperature of each stimulus, which we expect would introduce a lot of variability, but provided practical insight for the design of interactive systems. For simplicity, we'll look first at our results for just block 1 of our experiment. First, recall that the color temperature illusion should lead us to believe that red objects are perceived as colder than white and blue ones, and blue ones should be warmer than red and white objects. Looking at the results in block 1, we do see this, with estimates of blue being more than 2 degrees warmer than red. However, this result is not significant. So why didn't we find a significant result here? We interpret this in light of our experimental procedure. Recall that psychophysical experiment design that we mentioned previously is designed to reduce potential noise through a forced choice task. We potentially introduced a large source of noise by having people guess the temperatures. And while we see a fairly large difference, it's not significant. So we still believe that a color temperature illusion is likely possible in mixed reality. It's just that it's not a reliable and/or large enough effect to be detected by our experimental design. Now let's consider the dynamic graphic effects in block 1, including ice and fire. Recall that we were interested in whether things that we intuitively believed to be warmer and colder than colors might increase the effect size. And it turns out it does strengthen the effect. But what is really surprising is that it seems to reverse the directionality of the effect. Here we see that in block 1, that fire was perceived as the warmest and ice as the coldest. And there are significant differences here. Fire was significantly warmer than ice, and ice was significantly colder than blue. So why did we see the graphic effects have this different type of relationship with temperature than we do with the color temperature illusion? Well, we really don't have a good explanation for this. It could be that we have stumbled upon a new class of illusion that has a different sensory mechanism than the one that underlies the color temperature illusion. But also brings into question the idea that it is our expectations that causes color temperature illusion in the first place. Because if that was true, then our ice ball would have been perceived as warmer than the blue ball instead of colder. While we do not have a good explanation for our findings, we do believe that the logical next step would be to repeat the assessment of our stimulus, comparing colors and the graphical effects, but in a tightly designed psychophysical experiment to ensure that our results hold and to confirm whether this new type of illusion that we call the dynamic graphic temperature illusion does exist. Okay, so I've not presented the results for blocks 2 and 3, which we added to assess the effects of illusions over time. In blocks 2 and 3, surprisingly, we don't find any results. The significant effects of the dynamic graphics and the expected ordering on the different colors disappear in blocks 2 and 3. We believe this could have two explanations. First, participants might have become better at the task, despite the fact that we never told them that temperature were the same. Or, second, it could be that the exposure to the illusion themselves might have a diminishing effect over time. We believe this is another important finding that our work provides. Experimental approaches need to be devised for psychophysical experiments to examine the effect of sensory illusions over time. As we move into the future where display technology will be increasingly used to change or augment the physical environment, it's important for HCI researchers to understand what side effects changing the visual properties of objects might have. Our work departed from the previous experimental approaches in perception research that uses psychophysical experiments. We took an HCI experimental lens to better understand whether illusions might be something that could be designed for in mixed reality systems. By doing this, we may have found a new type of illusion that we call the dynamic graphics temperature illusion. And we have found that the assumptions about the underlying mechanism of a whole class of illusions should be reconsidered. We also provide important new directions for applied perception research, including the effects of illusion over time. Thanks for watching.